Hi, this presentation is for the analysis of an MLOps pipeline, purpose, components, and cloud compatibility. Today, I will present an analysis of machine learning operations pipeline, commonly referred to as MLOps pipeline. This presentation will examine purpose, scope, and key components of MLOps pipelines and analyze their roles in supporting machine learning systems in production environment. In addition, the presentation will explore how cloud platforms, particularly Microsoft Azure, provide infrastructure and tools to design, develop, and deploy MLOps pipeline. So, what is the machine learning system in productions? We can see that machine learning models are increasingly used in real-world applications such as recommendation system, fraud detections, healthcare diagnostics, and predictive analytics. However, deploying machine learning models into production environments introduce significant operational challenge. These challenges including managing data pipeline, ensuring reproducibility, monitoring model performance, and continuously updating data models as data change over time. Traditional software and engineering practices are often insufficient for managing this complexity because machine learning systems depend heavily on data and experimentation workflows. To address this challenge, the concept of MLOps have emerged. MLOps integrate machine learning developments with operational practices in order to support the deployment, monitoring, and maintenance of machine learning models in production systems. So, this presentation is organized into three main sections. First, I will describe what MLOps pipelines are, including their scope and main components. Second, I will explain the rationale behind MLOps pipeline, including their roles in machine learning maturity models, as well as the benefit and costs associated with the implementations. Finally, I will analyze how cloud platforms such as Microsoft Azure support MLOps pipeline and discuss potential opportunities for improving this system. So first, what is the MLOps pipeline? An MLOps pipeline is an automated workflow that manages the lifecycle of machine learning models from data preparation to deployment and monitoring. Unlike traditional software pipelines, machine learning pipeline must handle complex processing such as feature engineering, model experimentation, and continuous retraining. MLOps chain pipeline therefore aim to integrate machine learning development with DevOps practices to ensure that machine learning system can be deployed reliable and maintain efficiency in production environments. Research suggests that organizations increasingly rely on MLOps practice to transit from experimental machine learning prototypes to scalable and reliable production system. The scope of the MLOps pipeline extends across the entire machine learning lifecycle. This includes multiple stages such as data collections, data processing, feature engineering, model training, evaluation, deployment, and monitoring. MLOps pipeline also incorporate governance mechanisms such as version control, experiment checking, and model registry management. Recent research highlights that MLOps pipeline provide a structured framework for managing the full lifecycle of machine learning systems, ensuring that models remain reliable and reproducible over time. So, what are the main components of an MLOps pipeline? This diagram illustrating that the main components of the MLOps pipeline. The pipeline can generally be divided into three major stages. First, the experimentation stage, where data scientists prepare data, train models, and evaluate model performance. This stage typically involves steps such as data validation, data preparation, model training, and model evaluation. The goal of this stage is to identify best performing model through experimentation. Second, once a model is ready, the system moves to the automated pipeline stage, where these processes are automated for production environments. The pipeline automatically extracts data, perform validations, train models, and evaluate them into a repeatable workflow. This ensures reproducibility and scalability of machine learning system. Third, the validated model is stored in a model registry and deployed through a continuously delivery pipeline to provide predictions service. Finally, the deployed model is continuously monitored. If performance decreases due to data drift or change in the environments, the monitoring system can trigger the pipeline to retrain the models. MLOps play a very critical role in the evolution of machine learning capability within organizations. In a machine learning capability maturity model, organizations typically progress from manual experimentation to automated and scalable machine learning system. At early maturity levels, machine learning development is largely experimental and performed manually by data scientists. As organizations mature, automated training pipeline and version control mechanisms are going to be introduced. At higher levels of the maturity, MLPS pipeline enable fully automated workflow for data processing, model training, deployment, and monitoring. This transition allows machine learning models to be reliably integrated into production system and continuously improve over time. So what are the benefits of the MLPS pipeline? One of the main benefits of the MLPS pipeline is the automation of the machine learning lifecycle. By automating processes such as data preparation, model training, and deployment, organizations can significantly reduce manual work and improve efficiency. MLPS pipeline also improve the reproducibility by ensuring the experiment, models, and datasets are properly checked. In addition, they support faster model performance and better collaboration between the data scientists and engineering teams. Although MLPS pipeline provide many benefits, implementing them are also introduce several important costs. First, there are infrastructure and computational costs. MLPS pipeline requires significant cloud resources, including distributed storage, computing infrastructure for model training, and orchestration system to manage automated workflows. When models are retrained frequently or large datasets are involved, this infrastructure requirement can become very expensive. Second, organizations must consider engineering and development costs. Building reliable MLPS pipeline requires specialized expertise across multiple domains, including data engineering, machine learning engineering, and DevOps expertise. Developing automated pipeline, integrating different tools, and ensuring system reliability often requires sustainable development efforts and highly skilled teams. Third, there are tooling and platform costs. Organizations typically rely on a range of tools such as model registry, feature stores, monitoring system, and CI/CD platforms. Integrating and maintaining these tools increase both operational complexity and financial cost. Finally, maintenance and monitoring costs must also be considered. Machine learning models in production must be continuously monitored to detect issues such as data drift, model performance degradations, and system failures. This requires ongoing monitoring infrastructure and periodic model retraining. And research shows that these operational and engineering costs represent a significant challenge for organizations deploying machine learning systems in production environments, highlighting the importance of careful MLPS design and governance. So how to assess the quality of MLPS pipeline? Frameworks such as ML test score propose structured criteria for evaluating the production readiness and quality of machine learning pipelines. The quality of MLPS pipeline can be assessed through several key dimensions related to reliability, reproducibility, efficiency, and governance. First, reliability and stability are important indicators. A high-quality MLPS pipeline should run consistently without frequent failures. Automated workflows or for data processing, model training, and deployment must be robust and capable for handling large-scale data and system errors. Second, reproducibility is a critical requirement in machine learning systems. High-quality pipeline ensure the experiments and model results can be reproduced by checking data versions, model artifacts, and code change. This enables teams to debug models and maintain transparency in the machine learning lifecycle. Third, performance and efficiency are also key evaluation criteria. Organizations often measure how quickly models can be trained, tested, and deployed. Efficiency pipelines support continuous integration and continuous deployment, allowing teams to deliver machine learning updates more rapidly. Finally, monitoring and governance capability are essential for assessing pipeline quality. Effective MLPS pipeline include monitoring systems that check models' performance, detect data drift, and ensure that models remain reliable after deployment. Together, these metrics help organizations evaluate whether an MLPS pipeline is robust, scalable, and capable of supporting machine learning systems into a production environment. So cloud platform provide important infrastructure for implementing MLPS pipeline. Major cloud providers such as Amazon Web Service, Google Cloud Platform, and Microsoft Azure offer several services specially designed for machine learning lifecycle management. Cloud platforms such as Azure provide several capabilities that support the implementation of MLPS pipeline. First, Azure Machine Learning provides core functionality for managing the machine learning lifecycle, including experiment tracking, model training, model registry, and automated deployment. Second, Azure integrating with CI/CD tools such as Azure DevOps and GitHub Actions, which enable automated pipeline for testing, validating, and deploying machine learning models. Third, Azure provides scalable computing infrastructure and allows the organization to train models, use distributed computing resources, and large data sets. Finally, Azure support monitoring and lifecycle management enable teams to check model performance, detect data drift, and trigger automated retraining when necessary. Microsoft Azure provides several services that support MLPS pipeline. Azure Machine Learning offers tools for experiments tracking, model training, and pipeline orchestration. Azure DevOps can be used to implement continuous integration and deployment workflows for machine learning systems. Azure also provides monitoring services that check model performance and detect operational issues. Together, these tools enable organizations to build end-to-end MLPS pipelines, and that's help automate model deployment, development, deployment, and monitoring within a unified cloud environment. Although Azure provides strong support for MLPS pipeline, several opportunities exist for improvements. One area is data governance and linear checking. Machine learning systems rely heavily on complex dataset, and improved data transparency and linear checking would strengthen reliability and reproducibility. Another opportunity lies in automation and orchestration. While Azure provides multiple tools for pipeline automation, managing complexity workflows across different services can still require significant engineering efforts. In addition, standardization of MLPS practice cloud could improve collaboration and reduce system complexity. Clear frameworks for managing models, data versions, and experiments would help organizations maintain reliable machine learning systems. Finally, monitoring and explainability tools could be further enhanced to support responsible AI practice and regulatory compliance. To summarize, the key insight from this presentation, MLPS pipeline play a very essential role in managing the full lifecycle of machine learning systems. They allow organizations to move from experimental machine learning workflows to a reliable and scalable production system. By automating processes such as data preparation, model training, deployment, and monitoring, MLPS pipeline improve reproducibility, scalability, and collaboration between teams. However, implementing MLPS also introduces important technical and organizational costs, including infrastructure requirements, engineering complexity, and ongoing monitoring efforts. Finally, cloud platforms such as Microsoft Azure provide power infrastructure and services that support the development and deployment of scalable MLPS pipeline. In conclusion, MLPS pipeline have become a very critical component of modern machine learning systems. They integrating machine learning development, deployment, and monitoring into continuous and automated workflow, allowing organizations to operationalize machine learning at scale. While MLPS pipeline provide important benefits such as improved automation, reproducibility, and scalability, the implementation also requires careful consideration of infrastructure costs, engineering complexity, and organizational coordination. Cloud platforms such as Microsoft Azure play very important roles in enabling organizations to build scalable and reliable MLPS systems. Looking forward, further improvement in the governance, automation, and monitoring will be important for ensuring that MLPS pipeline remain effective and sustainable in increasingly complex machine learning environment. And here is the reference I use for this presentation. And thank you for your listening.